Good morning, everyone, and welcome to CSA Click. It's Microsoft's privilege to collaborate with CSA on this particular session that we're bringing to you around threat hunting for disguised adversary actions. I think it's really the sign of times that we're all gathered here and learning about this very important topic, how to all the different methods and latest trends around cybersecurity itself. And I'm also privileged to have my colleague Sharon Koh, who is in the global black belt of our advanced security analytics practice itself. And hopefully we want this to be a very informational session and also have you to be able to ask your questions, post it on the chat window that you see on your right. And there's also a survey as well. We'd like to get your feedback on how we're doing in the session itself. So again, a shout out to the CSA team, Jessica, Simon, Gokseng. A lot of them has worked with us behind the scenes to bring this session to you. So really, it's a privilege. And hopefully you will learn a few things around threat hunting here. And Sharon has been on the circuit quite a fair bit, sharing this very, very important topic. And at the same time, some of the best practices that we've seen, that we've gathered in all our experiences across Microsoft itself. So without further ado, I'd like to just push on to Sharon and have her begin the sharing session itself. Okay, thank you very much. And Sharon, over to you. Thank you.
Thanks, Richard. Sorry, I think we didn't skip through this slide.
No
So,
worries.
Richard, maybe you want to do a quick intro of yourself because you've done such a good job introducing me.
Yeah, no worries, no worries. I think well, some of the folks here do know me well. I see a very few familiar names with the colleagues over at CSA, but certainly some in the Singapore government agencies as well. So as you're all aware, I'm the Chief Technology Officer here at Microsoft Singapore. So a lot of times what I do is I do engage with the wider community here, whether is it across public sector as well as our commercial customers and partners. Really think of myself as the face of Microsoft's technology and our strategy in the whole gamut of the clouds and platforms and things like that. Just a little bit of history of myself. I'm born and bred here in Singapore, so fully Singaporean, but I spent about 12 years in the States, both in California as well as in the Seattle area. So I started my Microsoft career actually in Redmond. Was part of the team that built and founded and built Office 365 almost 14, 15 years ago already. So it's been a little bit long in the tooth on that. But I think as you're all aware, I think the whole cybersecurity landscape is evolving very rapidly. So again, we love for you to take this opportunity to learn about this important topic, and it's great that you're all investing time in yourselves to learn about this. So thanks again, Sharon, for that reminder. I always like to shine the spotlight on the real expert here. So I'll hand it back to Sharon again. Thanks.
Thanks, Richard. So, sorry, I'm going to have to turn off my video because I am having very bad bandwidth issues. But yeah, let's just get into some quick housekeeping rules before we get started. If everyone could please keep yourselves on mute so that we don't have any extra background noise during the event. And if you have any questions throughout the event, just feel free to drop any questions in the chat window as well. Or you can use the raise hand function. Richard is the moderator for this session, so he will help facilitate that as well. But we do want to try and keep the flow of the presentation going. There's a lot of content to cover, and we're already 7 minutes in on the hour. So definitely we have a fully packed agenda today. We have a full hour, but we do want to keep quite some time at the end for Q&A. So today, mainly, we will try and cover 5 topics. Number 1, around practical cyber threat hunting framework. Of course, you need to have a good framework to start with before we start delving into packages we want to use. And then secondly, it's also about identifying and prioritizing data sources. So thirdly, then we'll get into, after you have all the data, how can you actually analyze them? What types of tools can you use? And that's a very good segue into exploring Mystic Pi, which is our open source Python security package that you can actually utilize as well. So during the session, I will also show you some Jupyter notebooks with pre-canned data that you can actually download and use to kind of get a first-hand experience on how some of these widgets can be used to better help your threat hunting journey. And then lastly, it's about extracting insights and concluding a hunt, of course. Then we'll go, of course, into Q&A. So the first thing, of course, people will ask, what exactly is threat hunting and why is it so difficult for enterprises to actually successfully implement a threat hunting program, given that we know it's so important? And I just want to quickly give an overview on what are the types of threat hunting programs that are out there, because threat hunting could mean different things to many different people. At a very basic fundamental level, threat hunting could just be looking at atomic IOCs. So that's what you see at this bottom tier. So let's say you subscribe to threat intelligence feeds, for example. You get IP addresses, you get file hashes, domains. You want to do a quick lookup and search through all of your data, whether or not you perhaps have any machines connecting to this C2 server. If there are any, for example, malicious files that are existing on any of your servers or laptops. So that even in itself is actually an atomic threat hunt process. So it's very artifact driven. It is after the fact, actually. So it is when you already know that this is a compromised file, this is a bad DLL, this is a bad process, for example, and then you retrospectively go back and hunt for it. But today, what we mostly want to talk about is in the upper tiers. So it's looking for behavioral detections, which is based on tactics. We'll talk a bit more about MITRE later on. So MITRE, M-I-T-R-E. It's a very well-structured framework around all the different tactics, techniques, and procedures that attackers actually use. It helps guide you to make sure that you know that when you're doing your threat modeling, when you're considering what exactly are you looking for, that you have a very comprehensive consideration around what attack vectors you're specifically trying to hunt for. Now, in the third and highest tier, anomaly detection, and you can see here we state that it's actually quite a manual process. When I say manual, I mean determining whether something is anomalous or not. That requires a lot of human judgment, right? The process in itself of gathering data, the process in itself of running the algorithms and the models through is not manual. But the manual piece is where you actually look at the conclusion, look at the results and say, hey, yes, based on my knowledge of my enterprise network, I know that this particular server should not be talking to that other server, or this user should not be doing RDP activity into that server, for example. And of course, you can see on the left, there's a bunch of very complicated looking arrows, but that essentially is really how the hunting process is. There is going to be a lot of back and forth. So as to discover, let's say you look at a certain tactic, you might discover that, hey, this particular process is anomalous. It's something that I might want to look into. It might therefore end up being a atomic IOC that you flag as a bad IP, a bad file hash, etc. Then it feeds back into this loop where you go back and hunt and see which other machines do I see this running on, right? So it's consistently an iterative process that you would want to go through. Now, when we talk about hunting maturity model, I do like to reference the Squirrel HMM, hunting maturity model. Now, you don't have to start off in the rightmost tier, HM4, which is leading. Always start with baby steps so that it's not so daunting as well. And also bear in mind the leftmost column here. When we talk about hunting program, it's not just about throwing tools at it. It's not just about throwing compute power so that you can churn through your data. It's also about, number one, most important thing, data collection and hypothesis creation. Because when you try and boil the ocean, and there's a lot of data out there, especially when we want to go into, let's say, something like network hunting, that is going to be a lot of data. So because and unless you have unlimited resources, then by all means, do full PCAP analysis, grab that all down and dump it into a data lake. But otherwise, typically where we see enterprises starting is, let's take a more balanced approach. What matters the most to me? Where is the most critical? Where are my most critical assets? What is the most high impact type of attacks that I might be concerned about? Am I concerned about lateral movement, for example? Or am I concerned about privilege escalation and account compromise? Am I concerned about data exfiltration, which often is usually the first thing I see most enterprises trying to target as their hypothesis creation. So data exfiltration, for example, can mean many things. It can be data exfiltration through email, data exfiltration through USB drives, data exfiltration through other cloud, like for example your Google Drive, your Dropbox, etc. So there are many different points through which data can be exfiltrated, and that's what we're actually going to cover in the next section when we talk about how do you identify all of these different data sources. Because taking like an example of data exfiltration, what type of data are we talking about? Are we talking about database, where you have a SQL server and you have some user coming in to create tables, read tables, update tables? Or are we talking about files and documents, right? Oh, I don't really know how to draw a document, but something like that. User taking out documents, and how? Are they taking out via email? Are they taking out via a USB stick, right? Or how? So all these different considerations can sometimes be a bit overwhelming. And that's why it's very important for you to identify and actually prioritize these different data sources. So the first thing that would come to mind is doing a bit of threat modeling. There are many threat modeling methods available. So I've pasted this link here, and you will get a copy of this deck at the end if you do help us fill in the feedback form as well. But so there are 12 available methods. Definitely there are even more, but this is a good reference document gathered by CMU, talks about PASTA, talks about Stride, etc. Pick the one that's most relevant to you. But for today's session, I'm actually going to refer to the two models, one coming from CSA themselves. There's a link here, CSA Guide to Cyber Threat Modeling. There's also Microsoft's SDLC model, which also is based on Stride. So the two are very, very similar because we're both based off Stride. The only difference is CSA also adds in, how do I get that away? LM, which is lateral movement. So it's Stride plus LM. For us, LM is actually parked under E, so elevation, right? So it's similar. We're not going to have too many deviations in terms of our fundamentals. I will share some tools that you can actually use as well that we provide inside our website for free, so that you can better draw some diagrams, better understand your threats as well. So typically the process flows as per the bottom 5 segments. First, you start with a scope definition. You definitely don't want a scope creep because then it becomes a very big project. It becomes very overwhelming. Start with something small, discrete, so that it's manageable. Bear in mind the resources that you have as well. Then we talk about system decomposition, where I'll show you later on how you can actually draw out the different diagrams. And then we talk about threat identification, attack modeling, and then finally also how do you mitigate and actually validate that your mitigations are effective as well. So I'm going to skip some pieces around scope definition and just go straight into the key things to talk about today. When we talk about system decomposition, a big part of it is actually being able to create the diagrams. So when you create a diagram, it gives you a better understanding and a better appreciation of what exactly are the components and different elements, as we call it, that are part of this scope that you have already figured out. Right, so when we talk about an external entity, we typically use a square to represent that. That could be a person, it could be an admin, it could be a regular user, it could be a privileged user, for example. It could also be systems, right? So any square element, we actually use that to represent people or systems. Processes are represented by the circles. So these can be different web services, any components that you might have in between inside of your environment. Data store, very common icon that we use here. That's a cylinder. It represents not just databases, of course. It could also be a file server. It could be registry, shared memory, anything, right, that contains data for you. So even if, let's say, you have a cloud data store, right? A Google Drive, a Microsoft Teams SharePoint site, for example. That could also be a data store because there you also have mechanisms to log for access to that data, downloads, edits, uploads, etc. Now, data flows are represented by arrows. So that's where you can bear in mind, do remember that these are directional. So if it's bi-directional, then you have to draw it on both sides, right? So that gives you a bit more of an awareness and understanding of where and how exactly data is allowed to traverse. So it could be network traffic, it could be authentication attempts, it could be data flow, literally like we saw just now, out to email, out to USB. Now, trust boundary is represented by a dotted line. So this gives you an understanding of any logical or technical boundaries that you may have put in place, data diodes, firewalls, authentication mechanisms, etc. So RBAC controls, all those, definitely do document them as well, so that you at least know that this scenario is completely impossible because I've already locked it down, so that you don't waste time trying to hunt for something that definitely is not possible. Yeah. So essentially what your diagram will look like is something on the right. I'm going to zoom in for a bit. Just bear in mind we're continuing with the STRID concept. I'll talk about it in the later slide, but this is what you would architect it out to be so you have a better understanding again of how things are flowing. Now, what I did want to introduce was the Microsoft Threat Modeling tool. So if I just exit this for a bit and I think discard my ink annotations, when you go to that website link that I provided there, you can actually download this free Microsoft Threat Modeling tool. It's open source, it's for you to use. So you can continue to add and use this as a way to programmatically or better modify and share projects across the team, to say, let's look at something like a browser, for example, browser attempt. You can just drag and drop it here. Automatically will tell you this is an external entity, for example. That's why it's in a square. If it's a human user as well, it's going to be in a square, right? So likewise, if you want to add a data flow, you can add that and even mention what type of data flow we're looking at. Is it HTTPS? Are we looking at SMB, DNS? What type of flows are we talking about here? Yeah, so this is just a quick overview to show you what we provide. The next step, of course, is threat identification. So this was where there's a bit of deviation between the STRIDE and STRIDE LM model, but they're essentially very, very similar. So each of it stands for a specific type of threat. You have spoofing, which basically is impersonation, right? Someone pretending to be your CEO and sending out an email. We call that internal phishing as well, right? Trying to get finance to approve of an invoice by pretending to be a vendor. Tampering, that's to do with integrity as well. That's where modification actually happens. That's where we look at, for example, modified DLL or packets that get modified. That's much more complex, so we definitely will not be talking about that today. So tampering can happen on various levels. It can be something as sophisticated as packet modification, but it can also be something as small and simple as just trying to modify bits of data. Even, for example, not really brute forcing things, but even a password spray, for example, where a user tries to, modify certain, how should I put this? Where they can basically guess what your naming convention of, let's say, admin users are. So even if you don't use, for example, your official alias as out there, right? Someone could possibly even add in a new trusted admin on a local machine, and they know, right, what your naming convention is, so that it kind of hides itself from when you're doing your regular screenings, right? Because if I'm doing a hunt and I'm searching for, let's look for all power users, or let's look for all local domain admins, and I see that everything ends with a .admin, for example, and then I think that all of this is legit, right? But actually it's not. It's something that the attacker has tried to come in and try to do a bit of combination, spoofing and tampering together as well. Yeah, repudiation basically means that you are overwriting that you have not done a particular action, right? So this could even be in the most extreme form, doing things like clearing event logs, although that in itself is a very obvious vector that we actually look for. So security events being cleared, etc. That is something we do search for. Information disclosure, if someone has accidentally exposed certain information out as well, what is the likelihood of this being, for example, accidentally pushed? Especially when you have a CI/CD pipeline, for example, definitely you do want to consider whether there are safeguards put in place to prevent accidental information disclosure of secrets, of whichever, or accidental pushes that could go out there as well, that you might not be able to reverse in time. And we talk about denial of service as well, making sure that you know where are your availability points, make sure that you have WAFs in place, make sure you have DDoS in place, know which are the chokeholds, potential chokeholds, where you could possibly get DDoS attempts, self-DOS, etc. Elevation of privilege, this is very critical, especially when we talk about users and having rights on different machines. Lateral movement, of course, you can see it as distinct or as part of elevation of privilege also. This is where you can even have an attacker run something like a credential dump tool on the machine to extract local login credentials on other users that may have logged into that machine prior. Right? And it's a very simple thing to do to run a credential dump tool, so it's not as difficult as you might think it is. So the fourth piece is, of course, on doing attack modeling. So that's where I prefer to reference MITRE ATT&CK, but of course you're free to use any other modeling framework that you might have. So in MITRE, there's 3 tiers basically: tactics, techniques, and procedures. Right now, there's even sub-techniques that have been released. So within each, and I'll give you some examples, it really does depend again on what your hypothesis is. Because if, let's say, we're hunting for something like persistence, it could be, and it looks a bit complex and daunting, but let's say we look at one specific sub-technique or one specific technique of looking for registry key changes, where the attacker tries to load themselves into the registry itself. So within there, you need to start considering what data, what visibility do I need? And you can get that from 2 places. So you can have either sysmon, use event IDs 12 to 14, or if you want to log Windows security events, there's that whole list there as well, especially for 657, where registry value was modified. Everything else is slightly, it's still relevant, but it may not be essential for this particular use case, but always good to have additional adjacent visibility in order to better assess whether something truly is malicious or not. Because otherwise, you're just going to see a bunch of, registry key was modified and have no context otherwise as to whether or not this is malicious or it's a legitimate change. But for example, let's talk about hunting for compromised accounts, which might be a bit more relatable. Under initial access, and then this is your technique, and then the procedures. You also have valid accounts. So this means that a user's valid accounts is actually being used to do malicious activity. So essentially, it's compromised account that we're trying to hunt for. There are different types of accounts that you therefore need to note. You have on-premise accounts, you have cloud accounts, then you have domain, local accounts, etc. So definitely within each, there's going to be different things you need to consider. Take, for example, local accounts, local authentication events. In your Windows servers, there's definitely 4624, 4625, 4648, and 4675 that are essential for you to audit. So within here, it's kind of small, but I've also pasted in, what does each login type actually mean? Because you do need to know whether it's successful, it's failed. We even recently, I think, exposed interactive logins as a loggable field or mechanism. So you can look at not just user-initiated logins, but also things that are non-interactive as well. So moving into the next section on after you grab all the data, what exactly can you do with it? It's down to data analytics, as well as the techniques and tools that you might want to use. So there are typically 4 types of techniques, or I wouldn't call them models, that you would use. Think of it as regression, classification, clustering, and anomaly detection. But before you get overwhelmed by, should I be using SVM? Should I be using k-means clustering? Or should I use a deep neural network, etc.? Don't think about the model first. Think about what is your use case? What are you trying to do? So with regression, basically what you're trying to do is you have some predefined data, typically time series, sometimes not. And you want to basically forecast what does the future look like, question mark. So that's basically what we're trying to do with regression. It also is just another means for you to understand the relationship as well between two variables. So here you have X and Y. For classification, this is about, let's say, maybe I shouldn't draw this axis. Let's say something like that. How can I cluster that this looks like this, and this therefore means admin users. This is typically how my regular users behave, and this is how my privileged accounts behave, for example. So you can do classifications also. Typically, oh, that was a bad diagram. Classifications, we would do it this way, right, as well. So it looks a bit similar to clustering. I apologize, that was a very bad example, but you can use clustering for classification also. That's why it's a bit confusing. So classification also can be something like as simple as good IP, bad IP. Is it good, is it bad? That's a two-way classifier. Clustering, I apologize, I shouldn't have used the other example earlier. But clustering is also essentially about the same. So you have two axes again, maybe, or three-dimensional. It's really up to you what data you're analyzing. Clustering helps you to find groups where we can say, hey, this might be a peer group of finance because they tend to behave in this way and that way. And then maybe you have another group somewhere here that behaves a certain other way. So that's what clustering helps you to do as well. This one I'm going to remove so it doesn't make it complicated. But I'm going to say this is true or false. For example, just classify it as good or bad. Anomaly detection, slightly different. We are looking at, let's say, multiple data points where there is maybe a complete outlier from this, right? So it could be something as simple as a straight line, or it could even be something cyclical where we're looking at polynomial anomaly detection, and then you can add things in around trends and decomposing the signal further down. That's really what you're trying to do under anomaly detection as well. So more importantly, it's about the cybersecurity use cases. Under regression, you can actually use it to do things like PowerShell obfuscation analysis, looking at command line analysis, classification, pretty interesting. We had a Taiwan FSI customer where they were receiving a huge amount of WOF logs, and they were essentially saying, is there a way for me to use semi-supervised learning to actually classify whether and do some risk scoring on the WOF traffic logs that I'm getting in? So what they did was they did partial labeling of the WOF database that they had. And that gave us, for example, something to start off with that said, this is high severity to me, this is high impact, these other things are maybe not as important to me. We added in some other factors as well. So that's where something like feature engineering would come into play. So to them, the few things that mattered were, number one, what's my database of severity? Other things were, let's say, what's the country from which this IP or this traffic is coming from? And the other thing was, how often do I see it? How often, question mark. And based on a different weightage of each, 1, 2, 3, we assign different weightage just to this. We actually generated, ultimately, a risk score for them to tell them, yes, this is good, we deem it to be false positive, or this is bad, we deem it to be a true positive, for example. Now, with clustering, what else you can do is something like rare RDP connections. When you try and look at all of your RDP connections, can you cluster them into particular families or groups where it could indicate maybe time of activity, or it could indicate peer groups, right? Finance typically doesn't do RDP. I see a lot of my IT or my network team or my infra team doing a lot of RDP activity. So that's where entity analytics also comes into play. When we talk about anomaly detection, that's where you can even do things like looking at how each user in your environment typically authenticates to different applications, from where, what IP, what type of browser, and then come in to analyze which is an outlier from that point. This I might skip because we are quite tight on time. But essentially, you can also do things like looking at the variability in command line and process names. Certain things like cmd.exe, for example, you're going to see a huge variability because it is such a flexible tool, CMD and PowerShell, for example. So you'll see the low, high, and the median in between to exhibit a lot of variability. But perhaps some other processes that you have in your environment, things like collect guest logs.exe or some kind of even proprietary process that you may be running, a client that you're running on your machines, they typically should not be exhibiting such variability in their command lines as well. So then you would expect to see individual strains like that. If suddenly I'm seeing collect guest logs do something like this, then I might be a bit concerned and I would want to go in and dig a bit deeper and see why exactly is it suddenly running more commands than it usually does. Likewise, you can do the same thing for the paths as well. Where are they writing to? And typically, where it gets a bit more complex is that you might want to consider using a combination of techniques. So for example, when we look at anomalous sign-in locations by user accounts and authenticating applications, what we did here was actually to reduce the amount of false positives. On a 14-day time frame, 7-day time frame, and 1-day time frame, we did simple regression. So we looked at how a user typically authenticates to all the different applications over time. And then we will build out, for example, something like that, something like that, and something like that. So when we take 3 timeframes into considerations, it helps you to weed out a lot of false positives around this user is suddenly coming in from a new IP. New IP in 1 day could possibly not be new IP from 14 days ago, right? So maybe he went on leave for 7 days and then actually the data still exists in this window. So it's always good to take note of which window time frame you're looking at as well. And then we layered all 3 of this into anomaly detection. So then we did very quick time series decomposition on this as well, in order to help weed out whether or not that authentication is malicious or not.
Hey, Sharon.
Yeah.
Sorry, can I quickly jump in here?
Sure.
We got a question on the chat window itself, and I thought we just quickly share it. Simon had a question around on machine learning itself. So for someone who likes to explore using machine learning to hunt, which category would you recommend? I think people are digesting the classification and clustering and anomaly detection part of it. Do you have any thoughts on that?
Sure. Let me just come back to this slide. I would say the most accessible or the easiest one to start off with is anomaly detection. The reason why I probably wouldn't recommend the rest is because you typically need to have some sort of labeled data. So classification, for example, right? If you want to look for good versus bad domains, you would need some learning set first so that you can teach the algorithm or teach the model before it can help you do predictive classification, for example. Likewise with clustering, where it gets complicated is where you need to decide what is the feature that you're going to use to model these data points. Anomaly detection tends to be a bit more straightforward, where you are just asking literally, what is strange here, right? So it's a good starting point for someone who's just getting into threat hunting as well. It's very relatable, right? Where you look at things like, what is the, even something simple, bottom 5 percentile of processes that are running in my entire organization, which is the most rare IP addresses that I see logging in to my enterprise, for example. So even these very common questions we might ask ourselves can trigger a very good starting threat hunt point. Yeah.
Got it. Thanks, Sharon. All right.
No problem. So feel free to interject at any point. And also just very quickly, I would dump this machine learning algorithm cheat sheet here as well. After you've seen earlier, the 4 key things that you want to do, then comes the next question of what exactly do you want to use? Do you want to use a tool class SVM, support vector machine? Do you want to use something like PCA for anomaly-based detection? Do you want to do linear regression, Bayesian regression, etc.? Then this is where it starts to get a bit overwhelming, but definitely use this as a starting point first. Decide what do you want to do, what data do you have on hand, and then we decide what model best fits, because each one works very differently, and typically it depends on your hypothesis and your use case, as well as the data that you have on hand. Yeah. And so now I'm going to move quickly into the session on Mystic Pi, which is our open source Python security package. Within our package, we actually provide three main sub packages. One is security tools. This helps you to do data transformation, even simple things like how can I extract the base64 encoder portions of a command line, right? Or MB tools, which basically is more around data display capabilities. So I'll show you later on how you can do things like geo-IP lookups, how we can quickly plot on a timeline and alert event, alert timeline view, or even process tree view, etc. Data may or may not be so relevant in this case, but data is more for linking up and pulling data in from your Microsoft security products. So if you have Defender for Endpoint or Defender for Advanced Threat Protection, which is our EDR, our SIEM, Azure Sentinel, etc., all that data can be pulled in so that you can run Python scripts on top of them. So you don't have to use the native tools and be limited to that. You want to use pandas, you want to use scikit-learn, and you want to clump it all together on your security data, you can. We do make that available as well. Yeah, so some very quick important things to show you, and maybe I'll pivot over to the portal later if there's also time, is things like even geo-IP lookup, doing a quick VT virus total lookup. You can do it directly from your Jupyter notebook as well. So within here, you don't have to go and open a new page. You don't have to pivot here and there to a different browser portal. Everything can be done natively through your Jupyter notebook in itself, and then just do the presentation layer here. So if you want to look at how a user typically authenticates, usually they're coming in from somewhere in Southeast Asia. Suddenly I'm seeing traffic elsewhere, and I know that now it's COVID time. Definitely that's something for you to look into. Likewise, we showed you earlier, you can also do things like plotting your process tree. So again, it depends on your inputs. If you do log your Windows 4688 or your Linux audit events, then you can also testing.
Try again, Darren.
Okay, wow, it works for you. Nice. So yes, you can also do things like plotting a process tree, which is very important for a security analyst who wants to go in and see the spawning process, right? Which was the parent process that called this particular child process, and how did it continue on and follow? Even things like analyzing entity relations, and maybe at this point, I will quickly just pivot over to the slides here. So this is the CSA guide to threat modeling. I will also provide that link later on. But in here, you can see a Jupyter notebook. You can download this notebook as well for you to explore and use yourself. You can go in, look at event timeline, build out a swim lane in here. Some other things like entity mapping. So you can look at, for example, a particular process, which other users are maybe running that particular process as well, how the process is related to other child processes to help you better understand that relationship, etc. So all of these are our graphing modules that we provide inside there for you. Process tree, likewise, whether it's Windows or Linux, you can continue to look down and see how they spawn out in there. You can make it interactive as well, so that when you click, it actually shows you maybe the next question that you have in mind. Who else is running this particular process, right? Or how many times have I seen it in my environment from time frame A to time frame B? You can even look at event timelines to look at how the processes spawned out. If you're looking at beaconing activity, for example, a user that consistently has a process that beacons every 10 minutes, every 10 hours maybe, and is consistently sending packet sizes of 200 KB, right? That could be a sign of data exfiltration as well, and it's something you can look out for. All right, so quite a lot of tools here that we provide for you that you can leverage and use. We will definitely share this after the event, even looking at, for example, layer 7 traffic here. You can look into this, right? So split it down into the different protocols that we're using. so that you can better analyze if this, for example, is an anomaly that you might now want to look into. Now, the other piece that I wanted to show was around this. So especially during COVID, we noticed a lot of people have been asking, can I log my collaboration? It's in Teams usage, Zoom usage, Cisco WebEx usage. And the answer is yes, you can, because most of these vendors are actually providing you that visibility. So for example, what I'm doing here is my red nodes. These are external domains that my internal users in gray are actually talking to. So typical enterprise behavior, I would expect big clusters. I expect many of my users to be talking to CSA, for example, or GovTech, for example, right? So I would expect these big clusters, fairly normal. What I find strange might be side clusters. Why is Isaiah talking to against-COVID, against COVID-19.com? Why is, for example, admin talking to chase7-covid.com? So it doesn't have to be presented in this way. I like visual exploration. I like to manually explore data. So that's why I do it in this way. But you could have simply done a show me if connections are in bottom 5 percentile. Then you wouldn't even look at these. You would just immediately go into the logs and identify those 4 outlier strains here. Yeah, so you can even do something as quick and simple as that to do threat hunting for possible phishing attempts on collaboration channels or even data exfiltration attempts on those channels. So this is the final piece. I know I've been talking. Yeah.
Yeah, before we go on to the final piece itself, I got another question that Simon collected from the audience. It says, will you say that DNS reputation is more useful in hunting than IP reputation? Because IP may be from VPN services. Your thoughts?
I would say both are. Both are very tricky because of the way things are so ephemeral, right? And that ties it back to, earlier we talked about, if I can go back to that slide here, when we talk about atomic identification. Typically I dread searching for IOCs in IPs and DNS because I find that I end up spending more time trying to validate whether this is, especially if I'm using free threat intelligence, confidence is not that high. If you have a threat intelligence feed that is paid, that is really high fidelity, definitely I think you can put more confidence onto it. But still, IP, DNS, even file hashes, I feel file hashes are a bit more useful, at least still sometimes. If you can use YAML, for example, sorry, not YAML, YARA rules, that's actually even better for those atomic detections. But when we talk about IPs and DNS, that tends to change very, very frequently. It is very hard. But if I have to pick between the two, sorry, that's a very long answer, I would pick DNS for sure, because there's a bit more that you can analyze from DNS, because attackers typically would try and even use, for example, different subdomains, different names. You can even analyze that, right? Looking at the text, if you even want to go down into that level of, for example, here, text analytics, which in itself is a huge topic to go into, right? You want to do natural language processing. You want to start extracting out whether someone is trying to do a mock-up of, not a mock-up, but trying to phish you using a Microsoft or a Netflix or an AWS account, for example. Then they use MICR0, S0, FT, that kind of thing. Yeah, you can also use text analytics to look at that. So that's why I probably do prefer looking into DNS domains and subdomains versus IPs that tend to be very discrete and pump and dump. They just chuck them out very quickly. Yeah.
Got it. Okay, thanks.
No problem. Great question. Here. So thanks. I will conclude with how you can extract insights and actually conclude your hunt, which is the most important piece. Because very often, a lot of enterprises, they are done with the threat hunting, whether it's using open source tools like you've seen earlier, or if they use, for example, some of the vendor tools that you might have, right? So if you have an EDR in place, if you have a SIM in place, typically sometimes they do include threat hunting packages that you can just run and quickly look at the findings. Now, the big question is, now what do I do with the findings now that I see bottom 5 percentile of most anomalous processes, etc.? How do I make sense of it? So first things first, definitely do document all of your findings, please. Make sure good documentation practice, all of your notes are being made. If you find something particularly interesting, we have the concept of bookmarks in Microsoft, but however you might want to maintain your artifacts, put a star on it, depending on how you are consolidating all this information, definitely find a way to prioritize all these different findings. Now, this is when we get into hypothesis validation. So yes or no? No. Sorry, I missed out the yeses and nos. But validate your hypothesis first. If the hypothesis is wrong, you found that there were no findings or the findings were really bad, go back and take a look at whether your hypothesis was wrong, whether the data gathered was insufficient, was the analysis technique and the model that was chosen wrong in any way. So iteratively go back through that 5 process step that we saw earlier. Now, if you are saying that, yes, this hypothesis is valid, I do see compromised accounts, then the next question you're going to ask yourself is there an incident? So if yes, definitely start your incident response process. I tend to follow the SANS model, PySorl, but you can also use the NIST framework as well. Really depends on what is your preference for engaging in an IR process. Most importantly, I did want to mention there's a difference between containment and eradication. Containment is literally just saying, let me try and isolate and pull out, ring fence these affected systems. That part sometimes is fairly simpler compared to eradication, where eradication may mean that you need to seriously do a big sweep and look for any other backdoors that may be hidden there. There may be dormant backdoors that attackers tend to put as a backup option. So for example, Slorrygate, right? Don't really like to mention that, but there's instances where they actually did decouple the C2 beaconing process from a backup backdoor that they actually still kept somewhere further away, and they actually made sure that the two were not related as tightly so that you wouldn't be able to detect that the two of them were related, and you wouldn't be able to quickly remove both of them together as well. So eradication tends to be a bit difficult. This is where threat hunting really comes into play as well, making sure that all these other anomalous situations, other backdoors, any additional possible ways for the attacker to resurrect themselves inside your environment, because we've seen a lot of times where from here we don't do proper eradication, it comes back again, and then you get attacked all over again. You're like, why? Yeah, so definitely do take note of eradication process and how important threat hunting is in there as well. If thankfully you have no incident, then please do make sure also that your mitigations are functioning as intended. And also, more importantly, consider automation. So now that you've gone through this whole process of this one hypothesis, can you automate this process a bit more so that you don't have to consistently go in? If there's a logic where you can put in, right, to say that, yes, this is an incident, or no, it's not, or maybe I want to push a service ticket out to a team to go and do further evaluation, definitely consider doing these little things to reduce the manual effort that's required. Likewise, if we are talking about OT systems, do think about OT-specific IR processes, because that's going to differ very greatly from IT. I know today we spoke a lot more around IT side, but same thing is to be mirrored on the OT world. We cannot forget that on your CII and all the other OT SCADA-specific environments that you might have, the same thing could actually happen. Threat hunting in OT, handling incidents inside OT. Same but different. So do take note of those nuances and also have a plan in place for that. Lastly, I do want to end with consider open source tools. Things like, for example, Deep Blue Client, and I'll provide this link here for all the SANS free tools, a collection that they have actually posted. It's really great. Personally, I prefer using Deep Blue Client, but it's one of the good PowerShell modules that you can actually use to quickly run against your Windows events to have a look at things like suspicious account behavior, command line auditing, service auditing, even straightforward things like looking for Mimikatz, for example. So definitely do consider using some of these open source tools instead of reinventing the wheel and recreating everything from scratch. A lot of this is publicly maintained, great resources that you can leverage as well. So with that, I think we'll go into Q&A. And in the meanwhile, I'll just put the QR code here for feedback as well.
Okay, very cool. Thanks, Sharon. This was a really quick run through of all the various threat hunting resources and capabilities that we run. So folks normally, Sharon probably do this in half a day or in a day itself. So hopefully that gives you a flavor. We'll welcome anyone to come online. You can unmute yourself and pose some questions to Sharon. Anyone? Anyone? Don't be shy.
Maybe Sharon, this is Douglas
Hey,
Mann from
Douglas.
CSA. Maybe I help pose a question so that we can trigger some discussion. Yeah, since everybody
Good,
is
good.
quiet.
Always can count on you, Douglas.
Okay. So I'm from CSA Incident Response Team, and during peacetime we do threat hunting. But one of the very first question that people ask us is that uh, they want to do threat hunting in their organization, but how to start, where to start, and what to hunt for. Yeah. Is there a framework or systematic way that from what you have presented that you can advise the CISO or the management to go through a very structured and meticulous way to start the threat hunting process or program or project?
Yeah, that's a great question, and I wish we had one table or one document that could literally show this. Maybe I will try to find an example and share it at the end of the session with everyone as well, because the key problem, I guess, to what you're saying is hypothesis creation. Where exactly are the threats? What do I care about? If you're starting net new and you don't want to go about, first thing you can ask yourself is critical assets. Which are my critical assets? And then you start considering what are the attacks, etc., that you can consider. So that's the typical way you will line of thought that you will go down, and then data collection, etc., that you see here. If you're starting blank net new and you have no idea, number two thing I would say is start from attacks then. So look into MITRE, pick just one technique. Don't boil the ocean with everything. So like just now you saw account compromise, right? And let me scroll to it. Even something as big as or as simple as it sounds, like compromised accounts, is a very big hunt in itself, because then you need to reverse it, scope it down to which accounts are we looking for, which identities. Are we looking at API calls? Are we looking at user accounts? Are we looking at non-interactive sign-ins, etc.? Scope it down again, and then from there start asking yourself what exactly is the most important. So when you use MITRE especially, typically where we see enterprises starting is the low-hanging fruits. Things like, number one, I care about data exfiltration. Number two, I care about user compromise. It's fairly standard. Typically, we start with these big use cases, low-hanging fruit, show that threat hunting program can be successful. Then we move into the slightly more complex and data-intensive things like hunting for persistence, hunting for backdoors. This requires a deep understanding of systems and processes and applications that are running inside your environment. This might be a bit more daunting. Network, I'm not even mentioning. That one is fourth tier, man. That one is really, if you have time, resource to look through and scan through your network, that's great. Also, another consideration I would say is look at what tools you have in place, because if you don't have anything at all today and you have to roll out, for example, Sysmon deployment, or you have to roll out full-on logging deployment for your Linux and Windows servers, that might be a bit scary as well as part of the threat hunting program. So if you already have, for example, an EDR that is in place, look at what data your EDR gives you. Try and consider what hunting queries you can create from there first. And then we retrospectively go back and say, therefore, now I think I need to log these additional event IDs so that I can get the additional insight that I need.
Thank you, Sharon. Yeah, I think you started off with quite well. That is something that I guess to start with the low hanging fruit and work towards the tougher ones are. It's a good advice. Thank you very much. Yeah.
No problem. Thanks for the question.
Thanks, Douglas. Sharon, if I don't mind troubling you to put on that slide with the feedback form as well.
Oh, yeah.
Thank you. So we're just into the last, let's say 2.5 minutes. Again, just welcome anybody who want to pop in with the questions, or if you can't, just scan that QR code over there and also share with us your feedback on this session as well. Welcome any last question before we wrap this up together with our CSA academic colleagues.
Hi, Sharon. Can you hear me?
Yes.
Yes,
Hi.
Ryan, go for it.
Yeah, yeah. I'm Ryan. So I just want to check with you. Because the amount of data that is visible to the organization is greatly linked to the quality and also the quantity of the hypothesis that you can create, right? So my question is, what are the minimum or the recommended amount of visibility? Like you mentioned, if the customer has EDR, is a good place to start. Do they minimally, do you recommend at least they will have one side on the whole space like EDR, and then they have certain things like net flow and these few components that adds up to a valuable attempt to start threat hunting. What's the recommended baseline for a typical infrastructure to commence threat hunting?
Yeah, that's a great question. So definitely look at what you already have so that you already know that, no doubt those are things that you need. Host-based, like you mentioned, EDR, that is good. One thing here that I wanted to share, where was it? One common question we get is also which Windows event ID should I log? Because there's so many and I might not have the ability to actually use everything. So there is this event list, also another open source tool that you can actually use. In here, based on the Microsoft security baselines, we actually recommend that if you are interested in seeing a particular technique or tactic, then we would recommend that you log event IDs 1, 2, 3, 4, 5, 6. So that's also another thing. I would say, given recent events, it is very important for you to log your Azure AD and any authentication logs. Doesn't have to be Azure AD. Local sign-ins, that is one. So your 4624, 4625. But also any of the sign-ins that your users are doing, especially if you don't have MFA enabled, definitely good to look into your single factor logins as well. Non-interactive logins, anyone who is even doing things like logging into Office through PowerShell. Because account compromise is something that has very far-reaching impacts. That's why host is one thing. You want to look at last mile, but you also want to look at whether there's any tampering or any activity. That's a telltale sign that usually happens on the user side. So authentication, user activity, if you can have that as well. When I say user activity, I could mean things like the way they create, download, modify files. Could also be RDP activity that they're doing. So anything that touches the user. Network, typically, I have not seen that as something that people stand up continuously. It is usually more of a, now that I have narrowed down maybe that this particular group of machines is something I want to look deeper into, then I set up my network monitoring for that period of time, pick it up, and then do the analysis offline. If you do have the resources to do it 24/7, that's great. But typically, I haven't really seen that. You could also have a NBAT tool, right? Network Behavioral Anomaly Detection tool. So that one already does a lot of pre-processing for you, SFlow, NetFlow, whichever. PCAP header analysis. So if you have that as well, definitely leverage that tool instead of doing it yourself from the raw data. So in order of importance, that's just my point of view. I think host-based is one, authentication is the second one, and then network as well. Data would probably come as number 3. Network is always the last for me. But yeah, I guess that's the order of importance, I would say.
Okay, Sharon, thanks for that. I know we are a little bit at time, but two questions just popped into the chat window. So I thought we'll just stretch a little bit for a couple of minutes. And Sharon, if you can take them, that would be great. One is from Adrian Ong. He said, threat hunting seems to be hunting in the dark. Do you have a general set of hypotheses to start with? Okay, so that's one. I'll see if I can just slot the other second question to you, and you can take them as well. The other one is from Kia Ming. He asked, in the absence of true positives, how best do you usually demonstrate the value of hunting initiatives, especially to organizations that already have some security controls in place, AV, MSSP, some endpoint data, etc.?
Sure. Thanks. Great questions. First one on where could you start from? Definitely start from things that are open source. So in that sense, link as well as some of the other links that I'll provide. There are actually a lot of hunting queries that are already out there. So regardless of what tools you're using, so one thing that we try to do, for example, in Microsoft is we have, for example, 300 different queries here. And if you have no idea where you even want to start, what data sources you might have, we make it as simple as just run all displayed queries. Immediately, you can look into all of these different attempts here and then start to get an idea progressively, like users signing in to disabled accounts. It doesn't sound like much, but actually it's interesting to also then note that, hey, these IP addresses are trying to go after this. And I've seen quite a few attempts on, you'll see a lot of attackers trying to go to help desk emails or whatever public emails that you post on your website, like maybe help@csa.com, and then everyone tries to come in and brute force that. So you can actually get more insight into a lot of those activities there. Use some of that some of that traffic that you're seeing, the IP addresses, etc., to see if they're also trying on any other accounts inside your environment to actively do some blocking as well. So that's one thing you can do. Definitely consider other vendor agnostic queries as well. So this is vendor specific, but you can use it as a starting point. And then vendor agnostic, there are things like Blue Team, Sysmon, etc. that I'll share as well in this link here. And then to the other question on what if there are no true positives, then lucky you for sure. I would give myself a pat on the back if there was something that happened. And it does happen sometimes. Yeah, I've seen some environments that are very locked down and we see no true positives. Then the team is like, what do I tell management now? So one thing is no news, of course, is good news. That doesn't mean you can let your guard down. Second thing is sometimes we actually identify misconfigurations as well. So misconfigurations, although they may not have been exploited, but especially when you went back into this cycle here, ensure that mitigations are functioning as intended. Sometimes we do see lapses just because there wasn't an incident. They actually noticed it was by chance that the attacker still hadn't exploited this particular port that was left open, for example. So sometimes your threat hunts, they don't have to be based on those kinds of hypotheses of an actual exploit happening, but it could be something that is exploitable, right? So that's also something you can look for. And then lastly also is just consider everything out there, because there are so many different vectors, so many attack techniques. Just because this particular hypothesis didn't show up, didn't show anything, it doesn't mean that you cannot use the other hypothesis as a frame of reference to say, hey, have we considered this other threat? Especially as we move into cloud, a lot of things we are noticing that enterprises did not consider. If it's an environment that's under lock and key, that's hardened, usually you won't see much. It's quite clean. If you do see it, then that's all the more alarming. But think about all the other new environments, new connections, new external vendors that you're even letting into your environment as well. Yeah.
Okay, thanks, Sharon. Thanks. Those are great questions. And once again, thank you very much on behalf of Microsoft and the colleagues at CSA Academy that we collaborated with to bring you this session. Hope this has been useful, and please continue to scan that QR code and share with us your feedback. We certainly like to learn from some of your feedback, and then how we can future in the future have that privilege and opportunity to bring some of these sessions to you as well. So with that, I will take this opportunity to thank everyone and for your time that you're investing to learn about this, and hopefully to see you on another session some other day as well. So maybe back to my CSA colleagues, Jessica, Simon, over to you. Thank you.
Yeah. Hi, this is Simon from CSA Academy. Yeah, so a great shout out. Yeah, thanks a lot to Richard and Sharon. Well, I learned a lot, and there's so many things that actually we can explore further. So I would like to encourage everybody to give us your feedback. On the feedback form, there'll be a portion where you can just key in what else, what other topics within threat hunting that you would like to know, right? So and then so that we can then discuss Microsoft or our other partners to bring that to you in the next edition of our CSA Clip, right? So once again, thanks Richard, thanks Sharon, thanks for the Microsoft team. Yeah, everybody, see you soon. Okay, bye.
Okay, bye-bye now. Thank you, everyone. Thank you.
Thanks, Sharon. Bye-bye.
Thanks. Bye.
Thank you, everybody. Bye.
Bye.